Guys, happy Friday. I miss y'all. Can't wait to see you next week. Let's get started. Okay, so in the past couple days, we have learned how to find the area of a parallelogram, a triangle, a trapezoid, a rhombus, and a kite. Again, that video is still on Canvas. I'm going to leave it up there. You should still have your notes. Make sure you still have those notes. And today we're going to learn how to find the area of any regular polygon. All right, a regular polygon is a figure that is equiangular and equilateral. A figure that is equiangular and equilateral. Why is this not working now? All right, so I'm having to write it down here, but y'all get it. All right, a regular polygon is a figure that is equilateral and equiangular. Now, a polygon is just another word for a two-dimensional figure, okay? But that's the term that we use in geometry, so make sure you really understand what that means. And regular is what tells us that it's equiangular and equilateral. Now, equiangular means that all angles are equal. Okay, hence equi meaning equal and angular meaning angles. All angles are equal. Equilateral means that all sides are equal. All sides are equal. So if I were to draw a somewhat pentagon, close enough, right? It's a pentagon, 5 sides. All right, and I tell you that this is a regular pentagon and this side measures 2 inches. Well, that means that this one measures 2, this one measures 2, this one measures 2, and this one measures 2. And that also means that each angle inside that pentagon are going to be equal. All right, now the area of a regular polygon is related to the distance from the center to a side. The area of a regular polygon is related to the distance from the center to a side, as well as the perimeter. So hopefully you're familiar with a lot of these terms. Perimeter just means the distance around the figure. And we're going to go into the term for the distance from the center to a side in just a second. So before we move on, make sure you have your textbooks. Turn to page 629 and follow along. So if you don't have your textbook, pause this video, go get one, turn to page 629. Before we can start finding the area of regular polygons, we really need to get a little bit of background here. There's a couple things that we need to have a good understanding of before we can go into actually finding that area. The first thing that you need to understand is that any figure can be inscribed inside of a circle. So if you're looking on page 629, look on that right side there beside Essential Understanding. You will see a hexagon, a 6-sided figure inscribed within a circle. So this is what we mean by it's inscribed. I can draw that hexagon inside of a circle. I can draw a square inside of a circle, a triangle inside of a circle, so on and so forth. Okay? And then you see this term down here, circumscribed. Circumscribed circle means that there's a figure drawn inside of it. Okay, we're not going to get into that yet. That's next unit. But you do need to understand that if I say it's an inscribed polygon, that means it's drawn inside of a circle. All right, now, key thing here is that the center of the circumscribed figure is also the center of the circle. Okay, so this center is also the center of the polygon and that circle. So hopefully you've heard of this term. If not, we're going to refresh real quick. But if I draw a line from the center to that circle, it's called a radius. Hopefully you've heard of that before. It's a radius. All right. Now, if I were to draw from the center to this angle or this vertex here, it's called the radius of the polygon. So, newsflash, polygons can have radii too. Notice that this hexagon, this six-sided figure, oh, sorry, close enough. This hexagon is going to have 6 radii. And what's key to understand for radii, which is the plural for radius, is that the radius of a circle, the radius of a polygon, is going to have the same measure no matter what position you're going in. So if I tell you that this radius is 2 inches, that means that this one's also 2, this one's also 2, this one's also 2, this one's also 2, and this is also 2. And notice here that if I connect 2 of these radii, it creates a diagonal. Okay, and we're going to discuss how the number of radii, the number of diagonals all relate to the number of sides that you have. We'll get into that. It's really cool. All right. The other term that we see is apothem. And an apothem is the distance from the center to a side. All right, so a radius is the distance from the center to a vertex or a center to an angle, whereas an apothem is the distance from a center to the side. So if I draw from this center to this side, I have created an apothem. All right, and there's 2 things that you need to know about apothems. Okay, first and foremost is that an apothem, I'm doing the best I can. All right, an apothem is perpendicular to that side. We've seen perpendicular before. It means that it's creating a 90-degree angle here. Not only that, but an apothem is also an angle bisector. So an apothem bisects this interior angle here. All right, so look at problem number 1, or problem number 2 on page 630. Notice that I have given you a regular polygon reference chart, and I mentioned this early in the video, but it tells me how many sides are in which polygon and the name for that polygon. So an 8-sided figure is an octagon, a 10-sided figure is a decagon, 12 is dodecagon, so on and so forth. Keep up with this chart. We will use that later, okay? Now, problem number 2. We have here a pentagon, all right? It has 5 sides. Notice that because it has 5 sides, it has 5 radii, and it has 5 triangles created by those radii. Again, here we have our apothem, which is perpendicular to the side. So this is a 90-degree angle, 90 degrees. And notice that it's also bisecting this angle. Now to find, because this problem is asking for the measure of angle 1, angle 2, and angle 3. So we're going to start with angle 1. Angle 1 refers to this angle here. So and I think I mentioned this earlier, but the radii, these 5 radii are cutting the inside of this pentagon into 5 equal angles. So to find the measure of one of them, I say 360 degrees, and then I divide it by the number of sides. So even if I had a hexagon, I would say 360 divided by 6. If I said a nonagon, I would say 360 divided by 9. So 360 divided by however many sides are in that figure are going to tell you the measure of each of these interior angles. Because when you're dealing with a figure that has more than 3 sides, the interior angles, we'll get into that later. Okay, just for now, 360 divided by 5. And that's going to tell you the measure of angle 1. So 360 divided by 5. I just lost track of what I was doing, guys. I'm sorry. This is problem number 1, not problem number 2. Problem number 1, page 629. So when I say 360 divided by 5, I get 72 degrees. So the measure of angle 1 is 72 degrees. Now remember in the last slide I said that an apothem, which is this red dotted line here, is also an angle bisector. That means it's cutting this angle into 2 congruent parts. So if angle 1 is 72 degrees, that also means that this is 72 degrees, this is 72 degrees, this is 72 degrees, and this whole one here is 72 degrees. So if it's being halved by a bisector, to find the measure of angle 2, I take the measure of that whole angle and I divide it by 2, because a bisector is cutting it into 2 equal parts. An apothem bisects that angle. So the measure of angle 2 is 72 degrees divided by 2, which is 36. So angle 2 is 36 degrees. Now they're asking for the measure of angle 3, and I'm going to delete this here so we can kind of focus. But notice that the apothem along with the radii are creating a right triangle here. All right, and we've learned before how to find the measure of all 3 angles in a triangle. All 3 angles in a triangle will add up to 180 degrees every time, okay? So if I know that the measure of angle 2 is 36 degrees, and then we have a 90-degree angle, and that's going to lead me to find the value of angle 3. So 180 degrees minus that 36 minus that 90 leaves me with 54. That means the measure of angle 3 is 54 degrees. So hopefully you're starting to see by now that all of this knowledge, everything that you've learned from even day 1 is culminating, okay? It's all coming together. It's starting to pile on, and you're really having to apply what you've learned, okay? Let's move on to page number 630. Problem number 2. Okay, so now we're ready to find the area of a regular polygon. So let me give you that formula real quick. So to do that, you need to know that A stands for apothem. Ooh. A stands for apothem. And P stands for perimeter. All right. So the formula is the apothem times the perimeter divided by 2. Apothem times the perimeter divided by 2. So I know that you're probably looking at the worksheet going, well, this is all I really need to know. But I need you to stay focused, keep watching this, because what we're going to go over in the next couple slides, you need to know for next week. So let's get started. All right, we know that the apothem is 12.3. But we don't know the perimeter. All we know is that one side has a measure of 8 inches. Well, if you remember, regular polygons are equilateral. That means that all the sides have the same measure. That means every single side in this figure, this polygon, has a measure of 8 inches. So now what you can do is you can sit there and you can add up all of these 8s to try to find the perimeter. Remember, perimeter is the distance around this figure, okay? Or you can count how many sides you have, which is 10. So 8 inches per side times 10 sides means that the perimeter is 80 inches. All right, so apothem times perimeter, 12.3 times 80, and then we divide that by 2. 12.3 times 80 is 984. And if we divide that by 2, our area of our regular decagon with an apothem of 12.3 inches and side measures of 8 inches is equal to 492 squared inches. Remember, guys, we're dealing with area. We have to have our squared units in our answer. All right. I know that your handout says that just one more example, but there is one more thing after this that I want to show you. So find a spare space at the end of this slide where you can write that down. All right, so let's do this again. Apothem times perimeter divided by 2. Our apothem is 7.243. To find our perimeter, count how many sides you have. So 1, 2, 3, 4, 5, 6, 7, 8. 6 inches or 6 units times 8 sides means that it has a perimeter of 48 inches. And then we divide that by 2. So 7.243 times 48 is 347.664. And when we divide that by 2, that means our area is 173.832. Notice I'm not putting units, any specific units down here. However, we're still dealing with, let me drop below this and write it so you can still see it. But we're still dealing with area, meaning you have to have some sort of unit squared. So if I don't give you units, then you just write units and you square it. Now here's that last thing that I wanted to show you, and then we're done. This is a much shorter video than it was the other day. I gave y'all a word problem on Monday and Tuesday. And one of the word problems said that the area of a basketball court was such and such square feet. The length was such and such feet. What is the width of it? Okay, and that really stumped some of y'all, was working backwards to find that missing length or that missing width. So we're going to do another example of this. Okay. Then this is not in your book. This is one that I just made up. But the area of a regular octagon is 523 squared inches. Each side of the octagon is 4 inches. What is the length of the apothem? So remember that the area of a regular polygon is apothem times perimeter divided by 2. So write out your formula when you're given something like this and plug in the missing parts. They've told us the area, so that's going to be here, where area should go. The apothem is what we're trying to find, so we're going to leave that as A. So we have enough information here to determine the perimeter of that figure. Each side of that octagon is 4 inches. Well, an octagon has 8 sides. So that means the perimeter has to be 32 inches. So A times 32 divided by 2. Okay. So the first thing that we need to do is we need to get rid of this 2. And we do that by multiplying it out. If we're dividing by this 2, remember to move a value, you have to do the opposite operation. So this 2 is being divided. That means that to get rid of it, I multiply by 2. So I'm multiplying both sides by 2. So 523 times 2 becomes 1,046 is equal to A times 32. Divide by 32 to isolate that A. And that leaves you with 1,046 divided by 32 is equal to A. Now actually do this division here. And that means that our apothem is 32.6875 inches. Okay, and we're going to do more of these, but I wanted to really sit down and explain to everyone as a whole group of how to find a missing value if they give you the total. So we've been finding the area where we're given these two variables here. Well, that's not always going to be the case. They're not always going to just give you what you need on this side and you just plug it in and find your area. Sometimes they're going to give you your area and you have to plug in what you have and solve for a missing term here. And I'll make sure that we're doing more practice with this in class as well, because there are going to be questions like this on the ACT, and I know that really stumped a lot of you. So anyway, that concludes the video for today. Have a wonderful weekend, guys. I'm sure you're all behaving as I would expect you to for the sub. If y'all need anything, again, just email me. If you have any questions on this worksheet, write it down somewhere, put it in the basket to be collected, and I'll look at everything when I get back on Monday. All right, have a great weekend, guys. Bye.